So at first glance, it would be obvious to maybe hire a couple of computer scientists, right, who are really good at writing software, which is a nice skill to have. Fair enough. But what I found is that it's actually more important to have people who basically are good at translating a real world problem into a technical problem, right? A data science, machine learning, whatever problem. And I think astronomers are good at that. I also found that social scientists are actually very good at this. So they have this skill that you have a real world problem somewhere and you have to somehow translate that into tables with columns and rows that mean something and you can actually do analytics on.
Welcome to the Astronomers Turned Data Scientists podcast. Our guest today is Marcel Haas.
Hello, nice to be here.
Awesome. So you're our first guest from Europe that we've had. One of the questions I have is just like, what are some of the biggest differences between like a career in data science in Europe and in the US? That might not be the place to start though. So we can get to that later on.
Yeah, sure.
Maybe we can start more with like your origin story, especially like getting into astronomy or astrophysics at first and everything before the transition.
Sure, yeah. So that's ages ago, of course. So I was already interested in astronomy when I was a kid. So at about 8 years old or so, I sort of started reading books on planets and stars and all that, and that got me into it basically. And then at the high school where I was at, it happened to be the location where the Dutch Astronomical Society also had their regional meetings of, well, that area. And so I joined, and I was actually probably the only one under 65 at 12 years old, uh, which was great. So there were professors coming in giving talks, and I liked it. And they kept doing this month after month, and I kept going for years and years and years. And basically, from the very first year in high school, I was like, okay, this is what I'm gonna do. Right? I will be an astronomer when I'm 65. uh, and luckily for me, math and physics were, well, easy enough to actually pursue that. And I went for undergrad in Utrecht University in the Netherlands, and then I did my PhD in Leiden. So that was on computational astrophysics, mostly simulations of galaxy formations, those kind of things. And then so I graduated from that in 2010. Then I moved for postdocs to Baltimore Space Telescope Science Institute, where I basically worked on translating those simulations into observations somehow, looking at them with Hubble or with a virtual version of Hubble, and also James Webb, which by then was still supposed to be launched, I think in 2015 or so. Um, so we were planning for it, right? I stayed there for 2 years, and then a year before my contract ended, I actually transitioned to Rutgers in New Jersey, mostly because somebody I was working with a lot also moved there, and I just moved along, basically. And from there, actually, a year in, I decided to jump ship. So that's basically the short version before the transition. So
So yeah, could you tell us a little bit about sort of how that transition went? I mean, clearly you had experience with data science related skills and technical skills, but sort of, what was that transition like, and what year was that? I think it was around the same time
yeah,
as me, or maybe a couple years before me.
it was 2013.
Okay.
So
Okay. So
quite
yeah,
a
a little
while
bit before me.
ago, and that
Hmm.
was in the time that data science. I'm not even sure what actually was called data science here in Europe. So I applied to jobs in the Netherlands. So the transition was mostly for personal and family reasons. So I had two more years on my contract, so I could have stayed. But I also got a daughter back then, and then we were stuck there in New Jersey without family nearby. So I applied from the US to positions back in the Netherlands, which is kind of a weird thing to do, right? Because you back then, I guess it was not so normal yet to do Skype interviews. It was usually in person, but I did it over Skype, and that worked out. And actually, so I took a job with a healthcare insurance provider, and the main reason to take that was twofold actually. So one, a friend of mine worked there, and he said it was a fun company, and the other was, well, they hire me now I can move back and then I'll find a better job from there. That was basically the main thing. So I got into this team that was business intelligence department, right? So it was not called data science yet. There was no Python being used. So they used the SAS software, and that's statistical analysis software, I think. And it was even so bad that they called the whole team the SAS team, right? So it was not like a BI team. It was called after the software they used. So they were expanding that team to professionalize a little bit. So what they did was they cough up numbers overnight. Nightly batches of calculations were running, and they would produce static HTML pages with tables of numbers that some people in business used, and they were transitioning that mostly towards things that like dashboarding. So the dashboard was there, the dashboard was defined, but the numbers would only be calculated once people actually use them, which is a little bit more efficient, I guess. And the position was actually super easy. I just applied for that one job. They hired me, and I moved back. And then my plan was to move on from there, but I stayed for 5.5 years because indeed the company was fun to work for. And so the whole data sciencey bit in that was actually growing slowly over the years because I came in and I did, I downloaded a table with a SQL query and I calculate an average for a percentage, and it was, as complicated as it got typically. Funny thing was they hired me because of my experience with big data as an astronomer. And then the largest data sets I got to work with there were, under a gigabyte typically. So I was not completely impressed, but at least, it was a fun job in a fun team. And we got the freedom to explore a little bit more. We said, like, we can do more with this data. So we started doing machine learning like things. Basically all self-taught on the internet, just find stuff and repeat it, and that worked fairly well, mostly for things like fraud detection, and so it grew into a data science sub-team in that BI department, which was a lot of fun actually. But they didn't hire me for that, right? It just grew naturally, kind of, because this was the time that at least here companies didn't really do that much yet. Okay, the big tech companies, I guess, were doing it, but insurance and banking and so on, not much yet. Not much.
How big were the data sets you worked with beforehand as a astronomer?
Yeah, so the complete simulation set that I was using was, I think, something like 100 terabytes, but not at a time, of course, right? It doesn't really fit in memory. So it was cut up in 30, 40 different simulations, and that was cut up into 30 snapshots each in time. So the data sets we work with were typically, they would fit just in RAM of a reasonable machine. So like 20, 30 gigabytes per set, something like that. But bigger than the insurance company. The insurance
yeah.
company was also not the largest in the Netherlands, and the Netherlands is not a big country either. So what do you expect, right?
Mhm.
I'm a little curious about that, thinking back to that first job. It sounds like, you had motivation to take almost any job, in that kind of space that was offered. You had good motivation to move back to the Netherlands. That all makes sense.
Yep.
So, starting that off and doing, working with small data sets, taking sums and averages and relatively simplistic stuff, did you, at the time worry that, oh, this is not as intellectually stimulating as astronomy? Did you kind of see the writing on the wall that, okay, I can build up skills here and then move to a new job? Sort of what was the headspace there? Because that is a concern that I hear from a lot of people of,
Yeah.
I'm going to work on boring problems. They're not going to be as interesting as what I do in astronomy, not as complicated, et cetera. And that may be in some roles, but certainly not in many roles.
Very true. Yeah. So that did bother me actually. So the thing in the beginning, you still learn a lot of new stuff, right? You move from a domain like astronomy into a domain like healthcare insurance that I knew nothing about, right? So there was plenty to learn. It was just not technical skills. It was mostly how does this thing work with like billing doctors and those kind of processes. But yes, the reason why I was pushing for doing more with this data was because I was kind of missing that intellectually slightly more challenging type of work that I was doing before. Finding your own questions, like we think we can do this, let's try it. And I got some freedom to explore that, right? So that was nice enough, and it didn't take very long before that started. Just over half a year in or so. By that time, you still don't know much about that new domain. Right? But sometimes people worry about like the new technical skills or a different programming language is difficult, but that's something you learn in a few weeks, right? But actually moving into a completely new industry, that takes a lot longer to fully grasp, I think. So I was learning in the beginning about other things, and then I missed the nerdy stuff, if I can say it that way. And yeah, and that was why we tried to move into this data science business over there. But I definitely see the point that people might think that it's less stimulating, less intellectually challenging, and to me that was also true, and I think it's true in many, but certainly not all jobs. It's also like what kind of stimulus are you looking for, right? Sometimes it's also easier to just get the questions from somebody and work on them. You don't need to worry about finding your new question or whatever. It's like I think it differs from person to person what you look for in that area. And I think you can make the problems as complicated as you like if you want to. The thing is just that within a company, you of course need to stick to whatever they need done, right? I mean, they have a business to run, and it's not like a playground where you can just like do whatever you like. But yeah.
So in that first job that you were doing, did it develop, like by the end of the 5.5 years you were there, had it developed to a point where you were doing much more advanced stuff, or maybe was that one of the reasons you were looking to make a change from there?
No, in fact, after I think 3-ish years, we were doing I think pretty advanced stuff. So we're doing mostly things like fraud detection and risk analysis with slightly more advanced methods. So things that were at least stimulating enough for me and a couple of my teammates to figure out. And by the time I left, it was more because I was kind of done with the small-ish sized company, and I wanted to see more than just healthcare insurance. So I wanted to learn something new again, see something more of the world again. So that was the main reason to leave, not so much that it got too boring. Because by that time, actually, it was the first time where we were actually successful enough. So before we were called a data lab, right? It's called it like this all over the place. And in the beginning, that's experimenting, like a proof of concept. You see, in principle, we can do this, but before you actually do it in real life, basically, that takes a little bit more effort. And we were just about at that point by the time that I left. So that was still growing. I just wanted to see a large. So this was a company of 500 people. You know, it's not huge, and at some point, it's just you want to see some more.
Yeah, for sure. I actually was in a similar situation. I was at a company of about 300 people for about 5 years, and then decided, yeah, I want to try something different at a different company, different size company, different industry, like you were talking about. So I think that's a decent segue into where are you now? What are you working on now?
So I'm now 3 jobs further down the line, actually.
Okay.
So
Okay.
I moved from that job there into a consultancy job. So I became a data science consultant for a company that did most of what the company did was actually building software, optimization software. So it's mathematical optimization, things like planning routes or doing schedules for hospitals and those kind of things. And they had a consulting department of about 150 people in the Netherlands who did data science consulting. So wherever people would pay for the consultants, that's where we got sent to. Right? You do your thing. And because of my background in the healthcare insurance company, I was sent to insurance providers and to banks and pensions, financial industry mostly. That was half of my job there. The other half was in what we call the Analytics Academy. So we also had some sort of a educational program in which we did training in-house for a lot of companies that were just starting up their data science efforts and basically training people who used to be called data analysts and teach them Python and machine learning and all that. And basically kickstart their data science efforts. So that was the other half, developing training material, giving the trainings, which was also very cool actually. A lot of educational stuff. but I didn't quite like the very commercial environment of consultancy. So this was really getting your billable hours up. And whenever I had conversations with my boss, it was always about billable hours and the number of companies that you work for and how we can easily repeat the same trick that I did somewhere, we can repeat it somewhere else. I was like, not super exciting for me to do the same trick yet again somewhere else. And very often the assignments were also not very technical. So we were talking to the IT department about how they should organize their data science team. I think, okay, maybe you should install a Python server to do like to all work on the same computer, those kind of things. And that was really not what I was into actually. So I decided that I should move back from that very commercial thing to a slightly more public industry. So I went to water utilities, which was fun. We built an AI that was supposed to regulate or actually rule a wastewater treatment plant. So they have a couple of knobs they can turn, and they do, but pretty reactively typically, the operators. And we were building models that first of all would try to predict what would be coming in, what would be flowing in, and then try to optimize the settings for the machine to reduce the energy use and to reduce the nitrogen emissions from the machine as well. Which was nice. It was a cool project, but the company was really badly organized. So they had a couple of issues with digital cyber security, and whenever something like that happened, the leadership would just say like, okay, everybody who uses a computer in its everyday life will work on cybersecurity now. I can try, but I'm not very good at it. And this is super inefficient. And by the time my first year contract ran out there, I said like, yeah, thanks, but no thanks. I'll gladly move on from there. And in the meantime, I had also sort of figured out for myself that I was kind of missing the academic environment a little bit. So I was looking into more academic roles or roles at universities once again. I ended up doing policy for higher education for the University of Amsterdam because that was a role that was easier to get with a gap in your research CV than a researchy, than a tenure track job somewhere. So I did that for a year and a half, and that was data science for policy in higher education. So this was things like predicting student throughput and the money throughput in the university, which was actually pretty fun. And we also worked a lot together with the social science faculty, with a master's program there that was a data science program. We had students from that team joining us all the time. Yeah, that was fun. But in that time, I also got the opportunity to get the role that I'm in now. This is the last one, for now, anyway. Which is an academic role again. So I'm now an assistant professor at Leiden University Medical Center, which is, yeah, so that's a hospital, right? But they have a department that works on population health management. So this is kind of public health, but then combined with things like social issues and economic issues. So the interplay between health disadvantages and other types of disadvantages. And I'm doing the data science part there, obviously, because I have no clue about that domain yet. So I'm a data scientist there, and I work with the students who want a slightly more quantitative angle to that field.
One question I have is when you transitioned into data science the first time, it seems like there wasn't a whole lot of education that you needed to do to make that transition, but maybe there was some extra studies you were doing on the side over the years that helped you keep up with it, or was it all just on the job what you learned?
Yeah, so in the very beginning, so I joined this team that did SAS, right? And SAS is not quite commonly used in astronomy for good reasons, actually. So that's what I had to learn first, right? That was basically the only thing. This was like a 3-day course internally at the SAS company, right? So this is what they do. They buy really nice buildings and they throw a yearly global forum, as they call it, which is like a users conference, which is pretty well organized and a big party. So that took a couple days to learn, pretty much, and then all the other stuff was kind of on the job indeed. So I've been fighting for about 2.5 years to be allowed to use Python at that company, which I already used in my postdocs as well because I liked it. This is all dangerous, you know. It's open source and it all, must be insecure. So it took me a while to convince the people there that Python would actually be a reasonable choice and that it's not that unsafe. Um, so before we actually went into this machine learning bit, which you can do with SAS too, but it's not very convenient and it's a bit black boxy. But all that stuff with Python was indeed learning on the job because in astronomy I didn't use it much. I mean, I did a principal component analysis once, but I don't think you can call that machine learning by today's standards. So all that other stuff I did indeed learn on the job, mostly in the first job.
I'm curious, in your current position, are you teaching classes? Are you advising students in, I assume, in at least in informal ways, but also in formal ways? Like, how academic is your, current academic position?
Yeah, so officially I have 30% teaching load. In practice, that's a little bit lower because I joined this population health management department, which runs a master's program for the hospital. But that program is basically full, right? There are a bunch of courses, and the teachers who teach the courses are happily teaching the courses. So I do guest lectures every here and there. So there's a couple of quantitative like courses, like a course called Responsible Data Analysis and a course called Predictive Analytics. But that's let's say the traditional statistics way, or what they call in hospitals the epidemiology way. Um, so I then usually do like a morning or so with a lecture on some data sciencey topic with some practical work afterwards. I do work with thesis students, so the ones who want to do a slightly more advanced quantitative study for their thesis. I supervise them, so I had two last year and one this year. It's a program that has mostly social scientists and medical students as as their population, so they're not all as quantitative minded as we are. And by now, I also work with two PhD students, so they come from an econometrics and from a computer science background, so they are very quantitative. So we do things that are for the rest of the department. It's a little bit black magic, I guess, what they do, but we try to connect to the studies that are done by the less quantitative people and then give a data science angle to it. So those two are formally working with me, and that's a lot of fun. And the rest is, yeah, it should be research, right? So there's also a lot of work that is not actually research or teaching. So we have this data warehouse that in which we combine a whole bunch of demographics data with socioeconomic status related data, but also data from general practitioners, family doctors, or hospitals, or mental health care institutions. And we have that information for about 1 million people on the individual level. So that's a very detailed data set, but it's also very privacy sensitive, and therefore it is in a secure environment. A third party, a trusted third party that's trusted by everybody. It's the Statistics Netherlands. So that means that working with the data is slightly complicated, not because Python is complicated, but because getting access to the data is a pain sometimes. It takes a while. So there's a bunch of work in that too.
Do you have a favorite project that you've done at any point?
In this new role, I
In
haven't had.
Sure, in either in this one or anyone in the past, 10 years or so.
Yeah, so I think the one that I liked most is also that I worked on for quite a while was at the very first one, at the insurance company, where we did a fraud detection. So this was fraud committed by healthcare providers, actually. And that we just tried to figure out by a whole bunch of pattern recognition things. So the fraud detection department, or what they call the fraud investigation department, those were people who worked like the old school detectives almost, right? So they were looking at letters and compared signatures on one letter to another letter. That was the way they figured out most of the things. They were actually pretty successful at that too. Um, And then when we pushed this data science thing, we said like, I think we can, from their billing data, there must be signs that things go wrong every once in a while. So that's what we started doing. And the very first things that we did were actually extremely simple, right? We found a dentist that put 120 fillings in the teeth of his daughter. I mean, how did we not notice this before, right? Um, but that's the kind of thing when you start working with the data, and at after a point we started comparing, you know, the time series of like different providers that in which they built the billing cycles, and some people didn't seem to have a population of patients that somehow didn't go on summer holidays, for example. They just kept on billing, like all those kind of things that were slowly popping up when we did more and more advanced detection algorithms. And I think that was the longest running, but also one of the most interesting, because it was for me also the first time that seeing that you can actually find these real cases by doing, you know, analytics on the data.
Yeah, and that can have a big impact on the business too. So you could,
Yeah,
yeah,
yeah. So the interesting thing is that as soon as people, those providers, for example, know that these things are done, then they get smarter too, right? So it's kind of an interplay. If you start to catch them, they become smarter. So we could only detect signals, right? So we could say like this looks weird. That doesn't make it fraud yet, right? So that's when the fraud investigation department took off, and it took years before it got to a court case, for example. They actually, well, you know, got to a settlement typically, but at least when results were in. So that took a while, but for us it was just fun enough to find these things, regardless of whether it was used in the end or not. But the head of the dentistry department there was somebody who just would take an Excel file of about 1,000 lines, and he would print it on A3 format and take a marker and just see whatever he would find weird. Like, I think we can automate at least a bit of this, right? But then you're also taking their job away to an extent, so they were not all as willing to accept that. So there's an interesting interplay, right? So we thought like this is a no-brainer. We should do this, and other people were like, oh, I can do this just fine. So this is the type of thing that you don't really think about as a nerd doing these kind of things, but that you get confronted with when you try to do this in an environment with a lot of people who are doing this in a different way for years.
Yeah, I've definitely experienced that personally, and know a number of data scientists who have, yeah, gone into companies or industries where they've been well established. People have been, doing stuff. Advertising, ad tech is a place where I've done some work, and like, people have been deciding what goes into TV commercials and where and when to put those TV commercials for 100 years or 70 years, and they know best, and their gut feeling is way better than any model I can build, despite any kind of statistical argument I can make. So
I
yeah,
found
I
the
think
catch
that's
is that
pretty broad.
if the first thing your model does is basically telling them that their gut feeling is right, and you win the trust, and then you tell them something
Yep.
extra, that's where you win, right?
Yep.
there you go.
So I wanted to sort of building on that a little bit. I'm curious to hear what you're seeing and sort of predicting for the future in your current role, looking at sort of epidemiology related, public health related topics, and where you see sort of that kind of data related work going in the future, and potentially where AI is going to help or possibly hurt, and give us some bad recommendations going forward, right?
Yeah, great question. So I think so in this field where I'm in now, it's what we would like to call a mixed methods type of field. So there's a lot of quantitative work being done, but there's also a lot of qualitative research, right? So people actually interviewing others and getting knowledge out of very qualitative type of information, something that I would have trouble dealing with typically. Although I am working with some of them actually to work on this, but so with nowadays with all these AI things, I mean they can help sometimes, right? So the very simple thing is transcribing a conversation like we are having now, and just like let an AI write it down for you, right? And we run into interesting issues there, of course, because the interesting conversations there are typically about the health situation or the economic situation of people. And well, the first thing that people might want to try is just okay, send it to Whisper, right? Yeah. Throw this data to a commercial company down Silicon Valley somewhere. That's typically not what people want with that type of data, right? So I think there's a lot of promise, and in fact, I'm also preparing a first year's medical student program about promises of AI for them in the last week of their first year. Basically discussing like where is AI going to help doctors and population health in the future. And I think as soon as we get, well, first of all, the data in a better shape, right? It's very fragmented now. It's like in totally completely different data formats in different databases in different companies, and everybody is rightfully very protective of this data. So that is one thing that slows it down now. And then the other thing is you cannot just use any AI out there just for privacy reasons, ethical reasons. But you do also see that the open source variations of things like ChatGPT, right, the llamas, etc., they become better, more available, and you can actually just train them on a local cluster or even put a trained model on a laptop or a desktop somewhere, and then you could use it, right? And I think that there's a lot of potential there. We also see that some of these applications, especially of robots listening in with conversations, that's already actually helping out in everyday medical practice. And I think that's only going to become more. And it's not only listening to conversations, maybe also jumping in on the conversations and also doing things with image analysis. So in radiology, there's a lot of image segmentation, computer vision going on, helping in diagnosis. And there are still some fairness issues there, so they're not equally good for everybody. Let's say that, and those problems should be overcome or at least understood. And then I think there's a lot of potential getting virtual assistants for medical professionals. And I don't think that's very far away, actually. That's probably the next decade. I think we're going to see a lot more of that. So that's also the reason why the first years of this year actually are the first to get an AI and medical technology week in their curriculum. Of course, it's not the medical students themselves developing this, right? So it becomes actually quite hard to train these things yourself, right? It's a completely different skill than being a doctor, right? And you cannot learn everything. So I think there's going to be more interdisciplinary, or sometimes they call it transdisciplinary collaborations where everybody brings in their own angle. And what we see here is that these interdisciplinary things, so that requires a different way of working from both parties, right? So the people who do the tech part, they need to speak the doctor's language to some extent, but the doctors also need to speak the technical people's language to some extent. So by doing this together, they both need to change their everyday habits a little bit. That's only good, I think.
So in the field of data science in general, I don't know if you have a good sense of like some of the differences between working in Europe or in the US. Of course, you were only in the US during postdocs and a number of years ago. One guess I have, I know in Europe with GDPR, there's a bit more emphasis on like regulation and so forth, but maybe beyond that, you might have a better perspective and could shed some light on some of those differences.
Yeah, so I do think that there's that difference, right? So the focus might be shifted a little bit sometimes. I think it's also if you compare a couple of years ago to now, right? So 5, 6, 8 years ago, the data science was like everything that is related to data science was done by the same group of people, right? So we now have all these roles like data engineers and MLOps, those kind of things. That's a very recent development, I think. But it's not only on the tech part; it's also on the slightly more businessy part of things. So we have what used to be called business analysts. If that's in a data science team, it's typically called something like an analytics translator or so. So those are kind of the roles in between business and the tech people. And what I see mostly here is that those GDPR-like discussions, they don't play as much in the data science teams, right? So the very technical teams, they are, they get an assignment, they do it, and the fact that they got that assignment means that somebody at least said that it's fine to do it that way. And the GDPR exists, of course, but there's also, of course, the fact that you, when you work, especially when you work for a commercial company, and they have their own data, they can do with that data internally whatever they want, right? That's typically what you sign for. I accept the terms and conditions, check mark. So we see that in the public domain because we have a lot of, personal, sensitive personal data. There's a lot of regulations around that. But typically, so the only thing that I feel from that is that, it takes a while to get access. It takes a while to get permission to do what I want to do. But to a fair extent, that's just waiting for me, right? It's just I'm explaining to them, I want to do this, and I need this data, and I'm gonna do this with it, right? And then a machinery is gonna run somewhere with people in an ethical committee and those kind of groups, and they're just gonna decide whether this is fine or not. And it typically involves the data owners as well, right? So if I want to use hospital data and Statistic Netherlands data, then those two people, those two institutions are going to decide whether that's okay or not. I just wait. And when they say yes, I go loose. And when they say no, I just think of something else. That's basically how it works. And I think that is a more common thing. So that on the everyday business, I think many data scientists aren't really bothered. Except that, sometimes you think like, oh, it would just be great if we could just do this, and that might not be allowed because it violates GDPR. But I think it's more on the, you need to secure your data. You need to store it. Some data needs to be stored within national borders. Some data must be stored within EU borders. It's kind of a complicated system. But that's typically not the data scientist who cares about that, right? That's the people who do the database administration, cybersecurity, and the people who do the infrastructure, especially when it's cloud based, right? So the cloud typically has the most difficult part because you don't really always know where your data is stored unless you talk to Microsoft, Amazon about where the data servers are. And then I think it's also a matter of, people need to understand each other's language, and that was very bad a couple of years ago. It's a little bit better now, and it will be better in a few years. Years ago, auditors would be very afraid of hearing, oh, that's in an Amazon cloud somewhere, so the data is wherever. I think they sometimes interpreted the cloud really as something like up in the sky. You just like throw your data somewhere. And I think the understanding that means that it's in a data center somewhere, and that you can actually have a deal with Amazon about where that data center is exactly, even if you have it replicated over 2 or 3 or whatever. Then still you can say like, okay, this data needs to stay within the national borders, and that is something you can just discuss with them. It's totally fine as long as you pay. And I think that's just a matter of mutual understanding more than it's a technical issue.
So thinking about, the years you've been a data scientist, you've worked with data scientists, and now I think even working with students, I'd love to hear sort of what you look for in a colleague and a student and a collaborator, what kind of skill sets, specifically sort of with the bent of like skills that, astronomers, this astronomer turned data scientist podcast, what astronomers kind of pick up during their research that is a very transferable skill, something useful that you're, looking for that's really positive when you work with folks.
Yeah, so the thing I learned back in that first job again, I was allowed to hire a couple of people to make this data science team. So at first glance, it would be obvious to maybe hire a couple of computer scientists, right, who are really good at writing software, which is a nice skill to have, fair enough. But what I found is that it's actually more important to have people who basically are good at translating a real world problem into a technical problem, right? A data science, machine learning, whatever problem. And I think astronomers are good at that. I also found that social scientists are actually very good at this. So they have, you know, they have this skill that you have a real world problem somewhere, and you have to somehow translate that into tables with columns and rows that mean something, and you can actually do analytics on. Whereas the computer science people are typically not very used to real world problems because they are either very much on the algorithm development side or on the like maybe your school book type of problem, right? There's this data set and you use that data set because other people use it and people know the data set, and that's where you show your new algorithms performance on, for example. And I think that skill is very important. And I never looked for specific programming languages or techniques used before because I think all those things can be learned pretty quickly if you've been doing similar stuff before, right? So if you speak Python, you can learn R and vice versa. And if you have used generalized linear model, you can also do a decision tree. If you've trained a neural network before for computer vision, then you can also learn to use it for text analytics. And so I think it's much more important to be able to show what the relation is between your like the problem you want to solve and your tech stack, the way you're going to solve that, and how to explain this to people, right? Because you typically don't do this for yourself, you do it for somebody else, and those somebody else's are typically not so quantitative minded as you are. And I think that's true for like in the field I am in now and that I've been in forever, and it's even true for astronomers to an extent. I mean, very often your audience is an astronomy audience, so I guess it's similarly minded people. But you write a proposal not for your PI typically, right? You write a proposal for a committee that you don't really know and that do slightly different things. And the same with papers. I think proposal and paper writing are, even though they sound very much sciencey, they are closely related to working with a business department and doing your data science problem for them.
So I saw that on the side you have a craft beer hobby, and
Right.
I was wondering if for someone technically minded like you, is there anything that you're able to draw from that? Are you able to apply any of, data science to classifying or ranking different beers, or, how
Yeah,
does it
so
play any role, or is it just for fun?
it is just for fun, actually. I do also like the teaching aspect of it, giving tours and teaching people about what they are drinking at the moment. But interestingly, yesterday I was at a conference about beer. It was the first non-science conference I ever went to. But I also was at a talk by a Finnish guy who actually used machine learning to predict the fermentation process. So that
Cool.
was interesting. He just had a lack of data, but there was not a brewer in the room. He said like, "Oh, I have tons of data, but we never use it because we take the data because we want to know the number at that point. We write it down because why not, and then we forget about it. So who knows? I haven't combined much yet. So I've been playing a bit with Untapped. This check-in, like the beer you drink thing. They have an API, very low bandwidth, so you can only get limited amounts of data, but smart enough to, if you turn this on every couple of days, then you can actually get some information, but not much. Just playing around. Also, dealing with APIs is not my hobby, right? I just rather have a nice drink in my glass.
Yeah.
For a number of years there, around like 2015, 16, 17, there was a bit of a running joke between myself and a few other folks that went through the same data science boot camp program that I did, that like every other person that wanted to get a data science job, their side project was a beer recommender. It was just like one after another. And it was, it's very San Francisco Bay Area, Northern California kind of vibe, Silicon Valley style. But yeah, there was just so many beer recommender projects for so long there in the few year
And how
period. But
successful were they?
I mean, I have strong beer opinions, and I would always test them out, and like, they're fine, but like, it's one of those you can do a very simplistic model of like, oh, Jeff drinks in the Bay Area, so just recommend him an IPA and he'll probably be pretty happy with it. And like, yeah, that's true. So
Yeah,
you can make a pretty dumb one that works well for me, I guess, is my point.
exactly. Yeah, so I wrote a blog post a while ago about a brewer who used, they said we use AI to make the perfect recipe for it. I was like, oh, that's interesting because what does the perfect recipe even mean? Right? And
Right.
not everybody likes the same drink. And it turned out that what they did was actually just in a conversation with ChatGPT, they figured out some things that would be fun to try. And ChatGPT can actually write a reasonable recipe for you if you are relatively specific about what you want. So they said something about, okay, it's now fall, so what are the typical fruits that we could use in the Netherlands? And they came up with like apples or pears or whatever. And okay, so which ones should we use? And then apparently ChatGPT said, oh, don't use apples because apples taste like a common all flavor in beer, so don't do that. So go for pears. So they asked for, okay, well, what's a very popular beer style around here in this time of the year? So like, oh well, a triple goes well, the Belgian style. And then they made a recipe of a triple with beer, which is not common indeed. It was fine, not fantastic, but okay. But I was like, oh, they scraped all these kind of data of like beers that were good, and then somehow got like information on the recipes too. But in the end, it turned out to be just somebody talking to ChatGPT. Fair enough. Fair enough. I guess you did use an AI. That's true.
Oh, that's great.
So it didn't really go into this US versus Europe thing other than the GDPR, right? But that's maybe a good thing because I don't really know about the US very much. I do. So one thing that I did seem to notice a while, like a way back, was that um, in the US it seemed more common to have career tracks that stayed on the technical side and you can still grow, like status and salary wise. Let's say it that way. Which over here is less true. I think you need to go to management like roles, which is something that you must like, right? And it's something that's not for everybody, I assume. So that might be a difference. So there's no when there's very old guys in a very technical role here. It's mostly people who have been doing that same thing for 40 years, and the ones who are good, I guess, they are supposed to move up the ranks and lead people, which is kind of similar to academic career paths, right? You start out, and if you're a good grad student, you get a postdoc. If you're a good postdoc, you get a tenure track job, and when you're a good researcher, you move into a role where you don't do research anymore, which is interesting. But I guess it's pretty much the same in all industries.
Mm-hmm.
Yeah, that's interesting. It's I think it's sort of the default assumption in the US, but there are plenty of counter examples. There's plenty of, I mean, big tech companies and medium-sized companies that have like very high ladder levels for, IC, individual contributor, tech, forward, not people manager roles. And something, that I think biased against early in my data science career was like, oh, if you move to managerial, people manager side, it's a one-way street, right? And you're just kind of there, and then you do that forever. But I now myself have switched back, and I was a manager, then a director, and now I'm back to an IC, very high level IC, and that's cool. And I might switch back to manager at some point. But I know a number of people that have gone that way, and I know a number of people that have, stayed that very high level technical person, but still was able to, have title increases and salary increases as well. So it's certainly a thing around here, that's for sure.
Yeah. Yeah, I don't know of many examples of people who moved into managerial roles and then back to IC technical roles. Doesn't mean that it doesn't exist, right? So I think there are definitely people who don't like it and therefore switch back, but that then typically also means stepping back down in salary. Usually, maybe not always. I mean, I think the difference in salary it can be big between industries, right? Some industries pay a lot and some don't, and also commercial versus public companies that can make a very big difference, especially in the higher levels, right? At the starter level, that's still relatively similar. Yeah.
Yeah.
Grows faster. further in a commercial setting, typically.
I was wondering, what are there any really big companies in Europe that hire a lot of data scientists? I know the ones I always hear about are all based in the US. Maybe they have branches in Europe too, or are there just different companies that
Yeah.
hire a lot?
So we do have companies like the very big tech, so Amazon-like companies. So there's Booking.com, which is a hotel room booking website that's, I think, Amsterdam-based. Also, TomTom, for example, is there. And then there is, of course, the European branches of Amazon, for example, and Google and Microsoft. They all have a lot of offices here. They also have a lot of these combined research and R&D labs. So there's a Microsoft lab in Amsterdam that actually pays half of the faculty of the computer science department there. And, so there's a lot of that, those kind of tech companies. So we have a thing in the Netherlands that is pretty much like Amazon. So it's like a selling platform. It's called bol.com, which is really, I think it's the Netherlands only, but maybe they have a German website too. But it's very, very local, but it's pretty much the same thing. And that's also a few thousand people company that hire a lot of data scientists. And they have these teams where the data science is really about like one aspect of the website and trying to optimize it, like A/B testing on steroids, pretty much. And there's a lot of these comparison websites. So there's a thing called Trivago where you can also do things like travel comparisons. And I know of a few people who work there, and they said like, okay, you see that this part of the website, that's what we do, right? And they change a tiny little bit, and if that gives you 0.1% more revenue, then it's worth it, right? So then we put it into production. They keep on cycling through that, and then they change the teams every once in a while because otherwise you get bored, I guess. It's those kind of companies definitely exist here too. Yeah, maybe on a
We're getting
smaller scale.
we're getting toward the end of the podcast, so any final thoughts, Marcel? Any final advice, thoughts, reactions that you want to share with folks?
Well, maybe think twice before you actually do make the transition. So I noticed that I at some point was like, okay, I actually wanted to go back into Astro, for example. I'm now back in academics at least, and what I figured out was what I missed most was things like an academic environment, like having lunch talks, having a colloquium, those kind of things. Like the vibe that goes around at an academic institute is a little bit different than in an R&D environment in a tech company. And I started to miss that, and I realized that a little late, I guess. Going back into astronomy was, if you're geographically bound, that's very difficult, I guess. Getting back into an academic role was apparently possible, but it also took me a while to get there. I realized very late that that was the type of thing that I liked about being in an academic role, right? Being in that academic environment, not so much the actual thing you work on. And I think it's worth talking to people who made the transition, but also who did not make the transition before you do, and really try to figure out for yourself what it is that you think you find on the other side, and see what it is what you think you really enjoy in before the transition in astro science, and then see if you can find a role that gives you that aspect back, because I think it must exist. We have R&D companies here too that are pretty much science-like, and I think it can be important to find the right environment to work in when you make the transition. It doesn't need to be astro, doesn't need to be science, but I think it does need to basically keep the few aspects that you really do enjoy, keep that around. And that is something that I wasn't really thinking about when I made the transition. And that after the first job actually took me a quick rotation of a couple of jobs to figure out what I was actually looking for. I managed, but I think it would have been easier if I did this 10 years back.
Awesome. Well, thanks for joining us on our podcast today. If anyone in our audience wants to reach out to you, is there a best place where they can do that?
Yeah, sure. So LinkedIn would be great, or I'm on Blue Sky nowadays. I think that's the most active. I don't do Twitter, X, or whatever anymore. I have a Mastodon thing, but I don't use it very often. I think LinkedIn is the easiest. I will see that in no time, right, Jeff?
Yep.
Yes, thanks for having me. It was good fun.
Thank you for tuning in to this episode of the Astronomers Turned Data Scientists podcast. Please subscribe so you can find out when we release future episodes.